Hello, everyone, and I wish you a warm welcome to this presentation. So my name is Jean-Martin Lessard, I'm a PhD candidate here at the Lessard University of Sherbrooke. So this is the outlook of this presentation. All right. So basically, because of the prevailing linear take-make-waste economic system, we have witnessed unsustainable growth in resource demand, waste generation, and climate change as well. And so to tackle this challenge, now there's a growing consensus on the circular economy as a system of production and consumption that can bridge the economic, environmental, and social imperatives. So really, the intention of circular economy is really to shift away from this linear economic system by creating reverse logistic feedback loops across the system, and at the same time reducing this resource extraction and landfill amount of material sent to landfill, and really try to keep the highest value of in-stock material and end-of-use materials. So to have a successful transition toward a circular economy, a more circular economy, so we need diverse range of legislative, regulatory measure, investment, strategy, industrial roadmap that must be deployed. What we have to keep in mind is, like, if, as it is happening currently, everyone is doing such circular economy transition, and there are certainly overlapping between those strategies across a given economic system. So now let's look at this figure on the right. So we have a multiregional economic system. Let's say the yellow dot is like any given strategy to shift away from a linear economic system. So when we will deploy the strategy, we will affect the market equilibrium. So that we'll have like probably new suppliers and other conventional suppliers that would become obsolete due maybe to their GHG or energy or price intensity compared to the new circular input suppliers, if we can call it that way. And so before taking any decision, it's highly important, to have to be able to model or to capture those type of interactions. So what are those market-based, market-driven interaction within the system before taking any decision? That's where any consequential life cycle assessment might be really useful. This is the type of life cycle assessment that's trying, to capture those market interaction into the environmental impact assessment. But what the challenge remains that it's highly uncertain and difficult or complex, to identify what is being affected by the decision we are taking. So how to identify those marginal suppliers that are called, and by what order of magnitude? So this is highly complex to model. How does the coevolution of stakeholder over time influence this interaction? As I mentioned, now there will be interaction between different roadmap, different sector, different strategies and regions. So all this must be taken into account when we try to assess those market-driven environmental consequences. And at the end, ultimately, we want to know what are the environmental implications of those market adjustments due to our decision. So really, this was the purpose of this presentation, is to come up with a solution to be able to track those environmental consequences over space and time of measures that stimulate resource recovery, which allow to transit or to shift to a more circular economy. And so here an overview of the framework we have developed here at the Lessard. So we enhance consequential life cycle assessment with a least cost circular economic optimization model. So first, we develop our own economic optimization model that is a time series multi-regional material product chain model. I will provide more details in the following slides. That we pair the output to a consequential life cycle database, which is EcoInvent consequential system model, and then we characterize, what the outcome of this into environmental impacts using impact characterization method. Quickly, I forgot to mention, so why we have developed this. So there are currently a lot of optimization model across North America and Europe that are being developed. But most of the model that we have looked at in the literature, most of the model are looking into energy flows, optimization model that optimize energy flows, or are either a single region. So it was really necessary to develop a more material focused optimization model where we can have this new market competition between secondary material, primary material, and also savings in waste disposal. And that is as well multi-regional, as I mentioned, as I demonstrated in the previous slide. All right. So what's the time series multi-regional MP chain model we have developed? So quickly, it's an economic optimization model that is built on the mathematical framework of a material flow assessment. So it really captured those material flows, make sure that we have like a proper mass balance within all the system. It captured it connect all the production, consumption, and waste management chain of any studied industry in any given region. And what the model is trying to do is really to minimize the systemic all the costs, to satisfy a certain end product demand by varying the material composition of a product. So we can source either from virgin material or domestic virgin material, imports of virgin materials, and same thing for secondary materials based on the availability on the market and the price and transport and so on. So if I explode a little bit this box, this is a quick block diagram, what's happening, like how we generalize the equation within of this model. So quickly, we set a certain exogenous end product demand, and the model really try to optimize those type of flows from material sourcing to several type of loop that can be in competition, either like in reusing, closed loop recycling, open loop recycling, and this. And so this, what we've seen here, it's a single industry and single region description of any players in the model. And now we have scaled up this this model to be a multi-regional and multi-industrial, as we can see. So we have a different region that try to optimize their own supply chains to decrease their costs that are happening in different region, and all those regions can exchange material within this system model. So to demonstrate the relevancy of the proposed framework I just described, we apply it to the case study of the circularity measure to recycle post-consumer glass waste in the province of Quebec. So what's happening rapidly, it's that the province of Quebec is facing a challenge in bringing more value in their waste collection. So we do collect the glass waste through a curbside collection. However, the quality is very low, so there's not much industrial valorization taking place currently. So there are discussions of where investment should be oriented, to try to bring back in circularity those residues. So the two most major pathway, let's say, would be the one I'm gonna explore using my model. Is the first. So the first one would be, what if we improve the collect and we can sort the glass waste into colors, so we can improve this valorization in closed loop bottle to bottle, so taking the waste glass to produce new bottles. Or what if we develop an open loop system which consists of taking the current glass waste, crush it, micronize it super finely, and then it can be used as a cement substitute, just as any other fly ash or slag from the steel industry. So it can also be interesting in those two fields, and those are two pathways being discussed currently. So if we take a look of the two alternative scenarios, so would be the closed system and the open system, and both systems were compared to a business as usual scenario, which would be in our system there is no recycling possible. All of the glass waste must be landfill or stockpile in landfill as it is currently. The closed loop system, what's interesting to see here is that within this model, what's happening, it's like we bring, so in in the province of Quebec, it brings a certain amount of sorted cullet that can be either consumed domestically by glass producer, domestic glass producer, or can be either export to other region. There's a direct competition domestically or abroad with virgin materials. So like the sorted cullet that we use, we avoid or enter in direct competition with virgin materials to produce the same bottles. But also the domestic sorted cullet can be in direct competition as well with already imported cullets. So depend on the price of how the system react to this new availability of recycled material. And the open system is pretty much the same, but instead of being a closed loop, so within the same industry, it implies several industry that might be located in several regions as well. So the amount of glass product brought to the market can be in direct competition of the domestic market with fly ash slag, mainly because it was demonstrated in the literature that it shows very interesting properties in the cement production. It's now in direct competition with virgin material to produce blended cement, and as well as other imported fly ash or blast from the slag furnace, within the market. So this is our three different systems, and the consequence of each of the alternative system, the closed and the open, were compared to the business as usual scenario. How we made the resolution of the model. So first, on the left, we can see the regional resolution. So we had the province of Quebec as a main focus. Then we try to capture the historical trade partners for such materials, either glass cullet or supplementary cementitious material, or like cement substitute. And so we came up with those 6 aggregated regions. Then for each region, we have characterized this industrial network, industrial symbiosis, where we have like blended cement, glass container producer, and we have like this market, and all of those flows, of course, are regionalized in terms of availability, price, technology, material cost, demand. And we run those scenarios for 2030, 2040, and 2050. What changed from one time period to another is as it is written here. So we take the industry roadmap, we extrapolate some the data from that is available on the online and then in the literature, and then we came up with new demand, new capacity, and new technology that's coming into play up to 2050 for each of those sectors and in each of those regions. So here's a quick look on what are the feedback we received from our modeling. So here what we can, it's of course a simplification. What we see here, for instance, the red arrow would be displaced flow or avoided flow, and the green arrow would be new added flow due to the decision in the province of Quebec. So this is the closed scenario. So what we can see, for instance, is that we avoid 150 kilotons of waste, of glass waste, to the landfill that is now available on the recycled material market. But there is really low recycled material, cullets being absorbed domestically, simply because there are very low, actually almost no glass bottle producer in the province of Quebec. So there is no market anyway for those glass cullets. So, but they find takers abroad, mostly in the northeastern US. Then we've run the same thing for 2040, 2050. And then what's happening is that we can characterize, this production inventory into environmental impact. And what we can see here, so we can see the closed scenario, the impact is decreasing. So this is good. We reduce the climate change impact, for instance, here. What we can, it's interesting, is like we see it's decreasing for the province of Quebec, but also there are benefits, cross-border benefits, so in the Midwest and Northeastern US, and this is because of those market indirect market adjustment that we can capture through our modeling. And in red here, it's like the cumulative total of what's happening here. And we've processed the same for the open scenario. So again, so what if we valorize or recycle glass waste into glass powder as a cement substitute? So what we can see is like all of the glass powder can be absorbed domestically in the province of Quebec. By 2030, the cement producer should actually, if we, according to their own roadmap, they should actually already consume a lot of this type of material to try to reduce their environmental footprint. So what's going to happen is this new added glass powder would displace some fly ash imports that were coming from the Midwestern US, and this surplus of fly ash can be redirected toward undersupply market within the rest of the world, where we can those undersupply market now can have also see some benefits. So we conduct this optimization for 2040, 2050. Pretty much the same. We see there was like a shift in the market equilibrium, and this is pretty much what we see. So basically, it is negative, which is good. We decrease the climate change impact. Here we see that the province of Quebec see quite a bit of benefits, but the rest of the world, due to this this surplus that is created on the market and now can be used to feed on the supply market. And so when we compare side by side those two scenarios, closed and the open scenario, so we see both generate benefits globally in the economic system. So whatever decision is being taken is the right way to do, we must shift away from this business as usual scenario, of course. Here, what's interesting compared to a classical life cycle assessment, we are not comparing like two functionally equivalent system, but it's really like we are comparing what are the market driven environmental consequence due to two different pathways that they don't produce the same functional unit, but still we can compare their market effect this way. So another thing also that can be interesting is like we see those are the decrease for the closed and the open loop, but we have to keep in mind, as I've just demonstrated, that 55 to 94% of those environmental benefits, even if the decision is taken in the province of Quebec, so 55 of 94% of those benefits are felt in another region due, to those market adjustments. So circular economy measure can cause far-reaching ripple effects in geography dispersed market with unattended environmental effects. So this is what I've just demonstrated. So some key points now. I think our framework is really useful in that sense that it allows to better understand how competing industrial symbiosis influence each other environmental performance over time, as I just demonstrated. It's important to better anticipate those potential interaction within an economic system. And in the end, of course, what we really wish more globally is really having a better coordination across jurisdiction to maximize the overall environmental benefits, and let aside all the commercial dispute we all know now between the main country in the world. So yeah, we need to maximize the environmental benefits of our decision. Thank you very much.